So we're going to start playing with the trig functions, but as identities. And identities mean one equals the other. Identities are very huge in the upper level of math, where you have to prove that something new equals something old. So let's just start by looking at our friend, the Pythagorean identity. We've been going over with the unit circle why sine squared plus cosine squared equals 1. But like everything else, that can be manipulated. So, for example, if I were to take that identity and divide everything through by sine squared, we can do that. What we do to one, we have to do to all. When I divide through by sine squared, I get a new trig identity, but it really equals the same old sine squared plus cosine squared. Well, sine squared divided by sine squared is 1. Cosine squared over sine squared is really cotangent. Do you see why it's cotangent? Yeah, it's the reciprocal of tangent. Remember, tangent we learned was sine over cosine. And then we learned the reciprocals yesterday. So cotangent is cosine over sine. And then 1 divided by sine squared is cosecant squared. So there, you have a new Pythagorean identity. Likewise, you may ask yourself, well, I guess I can divide through by cosine squared, because I know that was your next question. You're like, well, what happens if I divide by cosine squared? Well, here you go. Let's just divide everybody by cosine squared. And I have yet a new Pythagorean identity. Sine divided by cosine, well, that's just regular old tangent. So that's tangent squared. Cosine divided by cosine would be 1. 1 over cosine is secant squared. So now we have 3 trig identities. And within these trig identities, we have more identities. What? For example, I could manipulate this. And I could subtract cosine squared and say sine squared is equal to 1 minus cosine squared. And you're like, oh, wow, Mrs. Trollin, if you did that, you could have subtracted sine squared and you could get cosine squared. Theta equals 1 minus sine. Oh my God, we're being attacked by squirrels. Everybody run and hide. And likewise, these new ones can also get manipulated. I could have started off with 1 plus cotangent squared theta equals cosecant squared theta, and I could have solved them all for 1. So 1 not only is sine squared plus cosine squared, but it could be cosecant squared theta minus cotangent squared theta. Or, well, 1 could have been secant squared theta minus tangent squared theta. Oh my God, the list of fun identities goes on and on. So stop your crying, and basically all I remember are these 3 right here. These are the big guns. Sine squared plus cosine squared equals 1. You have to know that one. That's dead cold. That's why a unit circle exists. And then to manipulate sine squared plus cosine squared into any of the other ones, we know we can just do our division. But knowing that sine squared equals 1 minus cosine squared and cosine squared equals 1 minus sine squared is huge. All right, so we have a bunch of identities. And here they are. I would take a screenshot of this, cut it out, and put it in your notebook. You're going to have to memorize all of them. And that means when the test rolls around, you won't be getting a little cheat sheet. You're going to have to know them all. Good luck. 1 over sine equals cosecant, sine equals 1 over cosecant. And then here are our trig identities down here. Notice this one, sine squared plus cosine squared equals 1. This is where I stay and I just manipulate. Here is where I divide through. So these are called our Pythagorean identities because they're all off the Pythagorean theorem. These are our reciprocal identities because they're the reciprocals. And then the tangent is sine over cosine, and the cotangent is cosine over sine. These are technically, one is the reciprocal of the other, but they're thrown in there. All right, so what do we do with these? We play with them. So for example, we were back to, oh, my favorite word in the world, proofs. Yay! But they're not like the proofs that you did last year in geometry. What you're trying to do is prove that this left side over here equals this right side over here. There's no need to put reasoning down like, oh, I did this because law of sines, or I did this because of if two sides are opposite, then the angle's opposite, then we're equal. No. But every step has to be clearly written. No crossing off so I can't read anything, because then you don't get any points. So here's how an identity proof works. We pick one side. Since we're proving this is not equal. We are questioning, does the left side equal the right side? So what you need to do is work one side until it looks like the other side. Now, which side you pick to work on all depends on what your brain sees. See, I can solve this one either way because it'll end up being a true statement. So most often, kids like to start with the more complicated side and see if they can funnel it down to the easier side. And notice over here on the right, I just have all of your substitutions that you're allowed to do. So, for example, I could start lots of different ways. But the most obvious way to kids would be this. 1 plus, and instead of cosine squared, some kids may come over here and say, well, every time I see a cosine squared, I can replace it with 1 minus sine squared. All right, well, I still have to get it down to look like this. What do I do now? Well, here is where your strength in algebra has to show. I can separate these because this can be separated into 2 fractions. You're like, all right, well, what does that do? Well, sine squared over sine squared becomes 1. And then 1 minus 1 becomes 1 over sine squared. And yes, you have to show each step. You have to show that we can clearly see that everything stayed the same from step 1 to step 2, except cosine squared was substituted for 1 minus sine squared theta. And then in step 2 to 3, we can see that nothing changed except you separated these two. And then from step 3 to 4, the 1 change stayed the same, 1 over sine squared stayed the same, but then sine squared over sine squared turned into 1. And then we were left with our final step. And then your final step is to write, yes, that does indeed equal the right side. Notice there was no work done on this side. We set out to prove that the left side can be manipulated to look like the right side. Now, we could have started on the right side and made it look like the left side. Here's that substitution we're going to do, 1. Well, look at all these substitutions for 1. I see 1 a lot in here. Well, I'm going to stick with the 1 equals sine squared plus cosine squared. I'm going to separate those two. To what they look like before we combine them into 1 fraction. And voila, look at that. Sine squared over sine squared is 1. And then I don't even have to change this. It's cosine squared theta over sine squared theta. And there's more ways to do this. You might have seen a different way. Because the truth of the matter is, all identities can be done multiple ways. I just have to write down my final step to show that one side does indeed equal the other side. Boom. So that's why, when I see this homework, if I see the same proof over and over again, I'm going to make it rain zeros. Because I'm sick and tired of the copying that's going on. Don't know what you can do when the regents rolls around, people. Sometimes they just ask us to rewrite as a single trigonometric function. So what does single trigonometric function mean? It means you can only have one trig function in here. Right now I have cosine and sine. So the either has to change into all cosine, all sine, all cosecant, all tangent, all something, but of only one. So cosine of x times sine squared x minus cosine x. And again, this is where your algebra has to be very strong. What can I do here? You have a lot of different things you could do. You could factor. Now, it doesn't help me with anything. I still have sine squared, but how strong is your manipulation skills? Over here, I see that sine squared theta plus cosine squared theta equals 1. Well, what does sine squared theta minus 1 equal? Well, if I manipulated this, sine squared theta minus 1 equals negative cosine squared theta. You're like, Mrs. Trollen, we never learned that. You learned that you can manipulate any of these and make them true. So sine squared theta minus 1 equals negative cosine squared theta. So over here, I'm going to substitute in negative cosine squared, and this time we're using x's over here. So this can be rewritten as negative cosine cubed x. There, we did it in a single trigonometric function. And yet there's another way to do this. Let's say you didn't see the factoring, because truth of the matter is most kids don't like factoring and wouldn't see that first. Most kids would have said, well, I would have saw this substitution, Mrs. Trulin, sine squared. Every time I see a sine squared, I can put in 1 minus cosine squared. Well, I'll distribute now, and I'll get cosine x minus cosine cubed x minus cosine x. Well, the minus cosine and the cosine x cancel out, leaving me the same answer, Mrs. Trulin, in a much quicker fashion. You're right. Aren't identities fun? Because there's more than one way to do them. Not only the way that, we know who you all copy from, doesn't we? All right, one more, let's try. 1 minus cosine squared times cosecant. And we want, again, a single trigonometric function. All right, so I'm just going to kind of stick with what I have written over to the right so we don't have too many meltdowns. 1 minus cosine squared x. Well, I see that that is a nice substitution. It's sine squared. And I like that because I know there's a relationship between sine and cosine. They're reciprocal functions of each other. So I'm going to choose, I could either choose to go two ways. Some of you could say sine squared. You're going to choose to make that 1 over cosecant squared and get cosecant x over cosecant squared x, which reduces down to 1 over cosecant x, which you could stop right there, or you could write it as sine x. Either place you stopped is correct because they said in terms of a single trigonometric function. Or some of you could have said, well, we're going to go this way, and we're going to take sine squared and keep it sine squared because we like our sines and cosines, and we're going to turn cosecant into 1 over sine, which gets us sine squared over sine when we multiply them together, which gets us sine, which again you could have kept at sine, or you could have turned into 1 over cosecant. Either way, we all end up in the same spot. All right, tomorrow we got to look at these. These are fun. Trust me, they're a blast.